Well, welcome to presentation number 2 of the day. We're happy to have Chris Brenton here. Chris is the Cloud Security Architect for Cloud Passage, the industry leader in hybrid IaaS security. He's also a fellow instructor for the SANS Institute. Chris is one of the founding members of the original HoneyNet project, as well as one of the original Internet Storm Center handlers. Chris Brenton.
Good morning. First off, email address. If you get out of here and get questions, I'll do Q&A at the end, of course, but you know, you always wonder out and say, oh damn, if I only asked, well, feel free to drop me a line. Why am I here? I have been living, breathing cloud security for the last couple of years. Been having an awful lot of fun with it, actually. I've been involved with a lot of the educational stuff through SANS. And actually, yeah, I was introduced as being part of Cloud Passage. I'm technically a bum right now. That's my new gig. I started on Monday, but I'm unemployed today, and it's actually been kind of fun. But like I said, I've been working on the SANS stuff, Cloud Security Alliance. One of the biggest fun, and a lot of what I'm rolling into this talk, is I've had a couple of environments I've worked with. 100% public cloud server environment receiving their PCI attestation. In other words, they do not have a single server as part of your, what you would call an internal network. Everything out in public cloud, Rackspace, Amazon, and quite honestly, this is the trend. This is the way things are going. So we'll kind of hit that as we go through. Where can I get these slides? You know, it's all going up on the interwebs. That's awesome. PDFs available up here too. Pretty easy URL to remember if you need it. And why is cloud so hard? I've been teaching cloud security to SANS for a while now, and one of the things I've noticed is the folks that have been at this for a while, like Jerry, who's been you know, hardcore in security for many, many years. Cloud security can be really hard to wrap your brain around. It's like, oh my God, what, you know, you want me to do what? And the attitude tends to be just say no. The newer folks who don't have the older crutches tend to kind of grab onto this and kind of run with it. This is coming. I'll kind of dig into this in this slide here, but this is something that's really, this is an industry game changer. I've talked to folks that look at this as being just like another technology. Oh, we had wireless. Wireless kind of changed things. No, this is beyond that. I've been around, so date my gray here. I've been around since this stage here, generation 1. Go back to the late 80s when mainframes were king and those PC things weren't even really considered part of the network. That's kind of, yeah, that's kind of how I got my start. I was the one that was sitting closest to this, you know, little Novell 2 something thing. But I remember the mainframe guys, and I remember them saying, oh my God, why would you ever do that? Your data is not centralized. You can't secure it. There's no way to centralize your authentication. Client server is never going to happen. We're never going to move away from mainframes. Well, certainly there's still mainframes and minis out there today, but it's certainly not how we normally do business, right? Through generation 2, it's been client server. We're moving into public hybrid now. I've dealt with a lot of companies out in San Francisco, especially New York City, where they may run 50, 150 servers, and again, not a single one of them on site. And literally their internal corporate network probably has less hardware than your home network. They've got a couple of wireless access points, they've got a NAT-based firewall getting them to the internet, and that's it. All the servers are running in public space. So I highly recommend you spend some time reading up on this stuff, getting up to speed. This is, like I said, this is the way things are going. Now, one of the biggest issues, I love this description. One of the biggest problems we have is we talk about the cloud this, the cloud that. The cloud, way too generic of a term. Because, you know, while it gives you some level of description about what's going on, it's, you know, about as useful as a mammal in this particular case here. So here's what you need to kind of focus in on, is the deployment models. So, excuse me, the service models. So infrastructure as a service, platform as a service, software as a service. You've probably heard these. Maybe you've seen this layout, maybe you haven't. But each of these little boxes is just part of our application stack. So if you think about, you know, like your VMware or your Zen or that type of thing, we're at about this point here or lower. everything that's involved to get up to that spot there. So our hardware, the need for electricity, the need for cooling, that type of thing. Build up on top of that, you've got your operating system, you've got your solution stack, whatever applications or databases you want to run, and then some sort of an interface. It might be web-based, it may be an API, whatever the case may be. And when we look at infrastructure as a service versus platform versus software, this little red line here kind of delineates the differences between them. In other words, when you go with a cloud service provider who's offering, infrastructure as a service like Amazon EC2, they're giving you this, you need to take care of that. Move up to software as a service, they're taking care of pretty much everything for you. You're actually going to have very little responsibility. Now, when we talk about PCI, it's all about allocating responsibility. So when we start talking about how do you get certified in the cloud, or how do you get your attestation in the cloud, where this line is and what solutions you're working with, quite honestly, is going to have an awful lot to do with how much work you need to do as part of that attestation. I'll come back to this a little bit later, but when you look at, I need my PCI attestation and I've got all my servers in Amazon EC2, when you look at how much work do I have to do versus someone who's got all their servers located in a data center, about half as much work, because Amazon's already doing all of that. So you'll hear a lot of folks say that, in fact, I noticed GuidePoint was one of the folks that sponsored this event. GuidePoint was actually one of the PCI auditors I just finished working with, getting attestation for one of these 100% all cloud environments. So you'll hear folks say PCI in the cloud, it can't happen. Oh, it's happening. And not only is it happening, it's actually becoming an easier way to do it. So when we talk about security, when we talk about, okay, this split responsibility here, vendor's going to take care of some of it, you're going to take care of some other stuff. If we talk about infrastructure as a service, which as we said, that's hypervisor on down. So vendors taking care of this, what tools do you have available to even work with? I tried to kind of map it out for you here. So each of the little blue lines are all of our different security disciplines, if you will. We could be working with authentication, we could be working with encryption, we could be working with centralized logging and alerting type of thing. What can we kind of pull into play? Well, I tried to kind of map them out here the best that I could come up with. If you're dealing with the platform as a service environment, move it up a little bit higher. Software as a service, you're pretty much leaving an awful lot of this to the vendor. So when you start looking at what are my security options, first you need to kind of pull back and say, okay, what possibilities do I have with the layers I want to try and secure? And there is no spoon, and there is no air gap. One of the biggest complaints I hear about cloud security is this thing here, the hypervisor that ties everything together. There's always that software connection. In other words, I can have a server literally running with no open listening ports at all, and technically there's a software conduit into that thing via the hypervisor. Is this a scary problem? Well, it's a problem. It's something we need to be concerned about. There's some things we can do. I'll talk us through that as we go through. But one of the things that I do want to kind of throw out is that what we wish for versus reality. In other words, what we wish for is to be able to run, one dedicated service per server, right? And this is actually part of PCI. What we end up with is, well, we need some place to run the NTP server. So we'll toss that on the name server as well. Or, we need to go in and kind of combine services. One of the things I love about cloud is it makes this so much easier because you're not talking about dedicating one piece of hardware or even a group of hardware to be able to build your own hypervisor, to be able to go through and create each of these individual servers. You can just spin them up as you need them. So let's talk about some of the things that'll bite you, or some of the things that may kind of burn on the backside. These first two here is the reason why public cloud today is the #1 source of attacks taking place on the internet today. Go back through history, and it used to be .edus, and then EDUs kind of cleaned up their act, and then it was home networks. And to some extent, it's still home networks, but from the data I'm collecting, public cloud is where a majority of this is coming from. And quite honestly, it's these first two bullets that are killing us. So you spin up a server, you go to your vendor's little web page that they allow you to go in and select what you want to spin up for a server. You spin that server up, and it comes up unpatched, with its administrative ports exposed to the world. Gee, combine those two together, what could possibly go wrong? Especially when you think about the number of RDP vulnerabilities we've had over the last year. If memory serves, there's at least 2, possibly 3, that I don't need to authenticate first. If I can get to your RDP port and you're not patched, boom, I own administrator on your box. It's that easy, that quick. And there are folks banging away on that on Amazon constantly, specifically trying to leverage this combination. So before you can get in, before you can spend a half hour, 45 minutes, whatever it's going to take to patch and get up to date, this is what happens. Now there's ways to fix that. I'll come back and talk about that towards the end as well. Employee public cloud sprawl. I love this one. Quick show of hands. How many of you within your company are using public cloud today for high value business? Okay, I see about 6 hands. I'd say at least 8 more of you are wrong. In other words, here's something to try. Here's something to try at your office. Go to your firewall log, okay? Do a reverse lookup on the management interface for Amazon and for box.net. Just look at those 2, and I can guarantee you're at least going to get 1 hit. In other words, most of us feel like, oh, we're not out in public cloud yet. You're where the mainframe guys were 30 years ago. In other words, the mainframe guys back around 1990 thought, oh, well, all our corporate data is still on the mainframe. And as we know who grew up in that era, oh no, we were throwing it on PCs. It was getting stored there. This is already happening. So if you haven't taken steps to try and control this yet, it's already getting out of control. It's something you really need to look at jumping on. Dealing with logs, that's a big one. That's one I'd rather take offline just because it's so huge. But like I said, this requires a complete rethink. This changes so many different things. One of the things that I had hand in was the early snort days and writing signatures and getting snort up to speed. So I have been, up until recently, a really big intrusion detection guy. But when you start talking public cloud, network-based intrusion detection, really hard, if not impossible to do. And here's our problem. Our problem today is our workloads are mobile. Now, a workload could be the entire virtual machine. It might just be, if we're dealing with PaaS, it might just be some applications that we're pushing out to public cloud. But servers are now portable devices. So in the old days, we used to say, hey, I'm going to build this firewall and have a nice glossy shell on the outside, and anybody who tries to get to my servers needs to get through that shell. Well, we're moving the servers outside the shell now. I'm working with companies that are writing, mobile application mobile apps, where they'll look at their statistics and say, okay, Verizon customers are pulling a lot more data right now. So what we're going to do is we're going to take our servers, push them out to Verizon's public cloud, spin up maybe a half a dozen of them, and now we've got a half a dozen servers 5 hops away from our customers, servicing their needs, so the application is very speedy, everything works great, and that offloads all the other work that normally would go off over to Amazon. So not only are we pushing them out to public cloud, we're leveraging the fact that there are so many available public clouds, we can put the workloads close to where we need them and moving them out that way. Well, if we're moving servers around, we've got to have security that moves with it. Because like we said, as soon as it goes across that perimeter, boom, it's gone. Now, luckily, we've dealt with this before. And again, for the old folks who have as much gray hair as I do, you remember the days when securing a desktop PC, not too bad because it was a desktop PC, it sat on the desk. Then they came up with these laptop things, and oh my God, we have to figure out how to secure them when they're in a hotel, when they're at a conference, when they got them on their home network, whatever the case may be. And over the years, we've developed technology to be able to lock down these laptops. We've got to start, well, we already are doing the same thing on the server side. There's some slight differences. One of the biggest differences is recognizing that resources need to be shared. If you've dealt with cloud management at all or security within the cloud, one of the things you probably ran into is AD storms. So if I've got, let's say, 20, 25 servers all running on the same hypervisor, and it's 2 a.m. and every server decides, hey, now I shall do a full disk scan to see if anything is wrong, boom, everything just dies, right? Why? Because that software was written in generation 2. In generation 2, if I'm a process that kicks off and I see, oh, 89% of the CPU is free, how much of that CPU am I allowed to use? 89%, right? So if all those servers look like 89% is free, guess what happens? Yeah, you all of a sudden are trying to use 103% of your CPU time, and that just doesn't work. And even then, it's still not enough. So one of the things we're starting to do today is we're starting to offload that work. So rather than do all the work on the server itself, do a minimal amount of work, ship it over to a server or a centralized SaaS solution that can go through, do the data processing there, and now all of a sudden we're not killing the servers anymore. So a lot of the technologies we've leveraged to be able to go through and secure laptops, we're moving that towards server side now, but like I said, it needs to be tweaked and adapted in order to work in the cloud environment. And there's other little gotchas that we've kind of run into. Things we haven't dealt with in the past. Things like, well, I delete or resize my VM, someone else spins up a new VM or makes those bigger. What happens to those data sectors on the disk where my data used to be? Well, now it's inside of their VM. To the best of my knowledge, all of the major US-based public cloud providers have fixed this problem. Yes, I'm saying that very specifically that way for a reason, because this problem is still out there, where you can spin up a VM and literally have all sorts of database information, at your disposal when you've never even installed database software on that system. Now, can you use this as a targeted attack? Good luck with that. There's just too many servers being spun up, spun down for this to ever be targeted. But that doesn't mean we actually want our information leaking out accidentally either. So how much of a change is public cloud? How much does this really kill us? Introspection, I think, is a great example of just how much we need to change and how much we need to fix things. Introspection, big push by VMware. This was what we were kind of looking at as, as we go into virtualization in the cloud, we shall use introspection and life will be good. And what we're finding out is, no, we can't go here. Introspection can cause some really serious issues. And I'll kind of talk you through this in case you're not overly familiar with it, just so everybody's kind of up to speed. So what is introspection? Introspection basically is an expansion of hypervisor capabilities. Normally the hypervisor will sit there and monitor and say, do you need CPU? Here. Do you need memory? Here. Do you need disk? Here. And that's about it. What this does is this allows me to basically jack in as if I was plugging into the actual cables to be able to monitor what's going on in memory, what's going on in disk storage, what's going in and out of that network card. And what's important to realize is that I'm doing it within the hypervisor, which means I'm not inserting software on the VM in order to do this. I'm doing it in the background. So what I'm doing is totally invisible to the VM itself. The VM has no knowledge of this taking place. Now, there's some really cool things you can do with this. Like fix my biggest boon, kernel level rootkits. A kernel level rootkit, excuse me, kernel level rootkit, for all intents and purposes, turns your operating system into malware. Your operating system is no longer an operating system. It is evil. And because it's evil, it's able to hide itself very, very well. It can be nearly impossible to figure out there's a kernel level rootkit on that box without shutting that box down, bringing it up on a known to be clean system, and then going in and doing a forensic analysis. Yeah, that's what I want to have to do every day when I got 150 servers to keep track of, right? So this can be something really hard to tag. However, with introspection, this becomes relatively simple to go through and find because the hypervisor is running with super privileges. It has a higher level of permissions than ring 0 on that operating system within the virtual machine. So that kernel level rootkit can't hide itself in the hypervisor. So from a security perspective, wow, I can do some really cool things with this. Like forensics, firewalling, malware control, as we were just talking about. So folks have been looking at this saying, wow, I can do some really cool things. Introspection is the way to go. We're actually, there's at least 3 public providers I can think of off the top of my head that will charge you extra money to implement this as a service if you want to deploy VMs with them. Performance benefits, that AV storm thing I talked about, it can fix things like that. So we've got better security, we've got better performance. What could possibly be wrong here, right? A couple things. First, how do we make code secure? Make it small and efficient, right? Now that doesn't mean I can't have a remote vulnerability in 5 lines of code. But certainly if there's a remote vulnerability that exists in 5 lines of code, it's going to be a lot easier for me to find than if it's in 5 million lines of code, right? So smaller, more efficient, better. This tends to kind of bloat out the hypervisor. Also, it allows third parties to get in and have direct manipulation of the hypervisor itself. Gee, what could possibly go wrong here, right? So now we're not only talking about the hypervisor vendor or open source group or whatever the case may be, we're talking about anybody who accesses that plug may potentially cause this thing to roll over and die, or worse, you know, introduce some level of insecurities. The other issue I have with this, introspection increases interaction with the virtual machines. So if my VMs are untrusted, I want a solid boundary between my hypervisor and my VM as much as possible, right? So think about it. You're spinning up an Amazon. Do you really want Amazon's hypervisor interacting with other VMs that may be insecure, which may now help somebody have a way to go in and compromise it? Probably not, right? And a good example of that is what we do with network-based intrusion detection systems. I used to piss off Marty Roach constantly in the early days because I loved finding these things. Basically what you would do, so let's say I want to go in and whack your network and I want to make sure you can't see me do it, I would create a specially crafted IP packet that would never hurt your servers, but as soon as Snort read it and tried to process it, it would cause Snort to roll over and crash. And in some cases, folks were even figuring out how to do privilege escalation. So they were figuring out how to get, this is again going back to the real early days, they were figuring out how to get Snort to actually execute commands with whatever level of permissions it was running with, which if you've ever run Snort, what do you normally run it as? You run it as root, right? So root level user, you're executing commands on that system that's supposed to be protecting the host. So again, you've got a box with no open listening ports and somebody can go through and own that. So this sending unexpected data that becomes difficult to process, as soon as we introduce introspection, we now open the possibility that that's going to happen in the hypervisor. Ooh, it's kind of scary. Because if the hypervisor gets owned, everything's gone at that point. Any VM that's touched that hypervisor now becomes suspect. The other issue I have with it, from a vendor perspective, introspection is awesome. Why? Because it locks you in. Because all this stuff works with that hypervisor and that hypervisor only. So if you bought in introspection products, if you say, okay, I want to move from hypervisor vendor A to hypervisor vendor B, you're not only just looking at swapping hypervisors, you're looking at swapping all of your security solutions that you've integrated with introspection as well. So it helps to support that whole vendor lock-in thing, which I'm not a big fan of myself. My biggest issue, though, is that it's providing uncontrolled access to the VM. So again, let's pretend Amazon decides they want to implement introspection. That means Amazon can now scrape any data off of disk, out of memory, or off of the network with your VM, and there's no audit trail on your VM itself. In other words, there's no login to look at to see if it was triggered, there's no file permissions or dates, timestamps, or anything else to look at, because it's all taking place outside of the VM. Today, to go in and whack Amazon, the best I can hope to get out of that really is maybe the ability to set up free accounts. I can't get to your data with the way they have their security structure today. However, if they chose to implement introspection, like again, a couple of public vendors have, this would be the first thing I want to go after. Because if I can whack introspection, I can now pull data off of any of their clients. And again, the audit trail to figure out this has even happened is almost non-existent. So my big thing, yeah, okay, I know we said we're going to virtualization and we're looking at introspection and introspection looks cool, and now that we'll plop a cloud on top of that virtualization, maybe we should keep looking at introspection to implement our security. My thing, no, not so much. Once you get this out in the public space, this really falls apart very quickly. So if the hardware, the hypervisor, the VMs are all private and all part of your corporate, and that's it, yeah, okay. Introspection may be something worth considering. But if you think you're going to go hybrid, and you're going to need security out in public cloud, not so much a good way to go. All right, so that's all the things that can bite you. What can we do? Well, like I said, a lot of this is still kind of work in progress. We're still looking at, tools like Tripwire, which we look at for file integrity management type of thing. And how do we adopt those on the cloud side? How do we get those to play nice when, you can't use 100% CPU all the time, that type of thing. So how do we get those to work? This is already happening. I'm seeing top 20 financial companies in the world pushing data out in the public cloud. Already past, okay, we're going to push stuff out there we don't care about just to test this, and just now starting to get into, okay, we're actually going to push out data that has some level of loss expectancy to it that would hurt if something bad happened. So we're already hitting that tipping point where we need decent security, and the tools are still kind of playing catch up to this whole thing. So how do we deal with this? My personal opinion, and again, this is just me, we need to push the security out to the lowest common denominator, namely the VMs. Now, when we think about virtual machines, we tend to think infrastructure as a service, but typically when you're running platform as a service, you got VMs you're working with as well. In fact, a lot of software as a service companies are built off of VMs. It's not uncommon to find, Acme Corp that sells, access to online widgets or whatever, that's a SaaS solution that have built their SaaS solution on top of some other CSP's infrastructure as a service solution. So when you start looking at what's our lowest common denominator to work with, it's this virtual machine. So if we can push the security out to the virtual machine itself, now take that workload, move it someplace else, you're still going to be in pretty good shape. One of the things I see some companies struggling trying to do is to try to do this at layer 2 and layer 3. In fact, we were talking about this last night at the Stogie Fest. So let's say I've got a public cloud vendor over here that I'm using, and I want to throw some virtual machines out there and I want to secure them. So I may try and set up a virtual firewall setup. Okay, well that takes care of the network side, doesn't really help me with the hypervisor side, but it's that, I had a crunchy shell over here, let me try and put a crunchy shell over here too, so it kind of makes sense to me, and some folks are going that way. And then what they do is they set up an IPsec tunnel between the two. So now in order to get to this VM, you've got to go through the firewall, you've got to go through that VPN tunnel, get access to the server that way. And for a Gen 2 security person, you sleep a little warmer and fuzzier because all of that's taking place behind your perimeter. So it's almost like that VM's behind your perimeter, so it makes it a little easier to sleep at night. Okay, upside, that's probably a decent way to transition and start moving. Downside isn't going to work long term. We're going highly mobile these days. Again, I'm working with companies that have grown up in Generation 3, where their internal network is a couple of access points and a NAT-based firewall to the internet, and that's it. And maybe half of their employees are mobile at least 90% of the time. In other words, they're not in the office. So the company I just left is based out of San Francisco. I spent at most a couple of weeks there a year, that was it. My direct report lives in Lebanon, New Hampshire. So he spent maybe 4 weeks a year over there, and that was it. Most of the company was mobile. Pick your talent, best place you can find them, and run with it from there. You're seeing more companies coming up in Gen 3 doing this. So if all my users are mobile, now what's happening to all my traffic? Well, now anytime you want to access that public VM, you got to come over that ISP link, get decrypted, go back out, get re-encrypted, go back out, come back in, go back out. You're saturating that link. So if I need to spin up 50 servers in public cloud, all of a sudden now maybe I can't because I might not have enough link speed with my upstream ISP. Oh my God, that's a horrible problem to get yourself into, right? I'm throwing my resources out in public cloud to leverage their asynchronous routing capability and all that good stuff, and now I'm going to throw it all away and try and tunnel it through again. So like I said, that might help you transition, but long-term, what's going to fix this? We've got to push it out to the VM side. One of the ways we're doing this is we're totally changing the way we build servers. Here's how we build servers classically. So I need a server, so I go through and build a server. You know, we need another server, maybe somebody else builds that server. We might have some general scripts we use to kind of build this stuff up, but we're kind of building them up as a one-off. And then what do we end up doing on the back end? We got to check every one of those, right? Because maybe Bob forgot to run the second script, or maybe Jim forgot to install patches, or you know, whatever the case may be. It takes a lot of maintenance on the back end, because since these servers are all being built differently, or slightly differently, even if it's just the human who's doing it, there's a possibility of them being different enough to be a security issue. Now I got to check it. The way we build servers today is with cloning. So with cloning, I build what I refer to as gold standard master. Here's what I want all my servers to look like. Here's how I want SSH configured. Here's the patches installed, whatever the case may be. I inspect that, make sure, you know, bless it as good, and now I just run off as many copies of that as I need. Well, what happens when patches come out, Chris? I go to my gold standard master, patch it, make sure it's working the way I expected, pull down all those images and reclone it. So everything always looks like the gold standard master. So long as my initial check is always okay, all of my clones are always going to be okay by default. So now if I need to burst out 150 servers, I don't necessarily have 150 more servers I need to manage. I'm going to leverage tools like RightScale, Chef, and Puppet to be able to minimize the security impact of that. So all of these, like I said, should be, all my clones should be matches against that gold standard. Well, this opens up some interesting possibilities. You may remember this in the Sunday paper when you were younger, right? What was this game? Spot the difference, right? So over here, the dog has something hanging on its collar. Here it's didn't. So here's a security incident in our case, right? Here's something that's changed. Let's see, the sun went away, that's different. The chimney's different. You get the idea. This is how we're going to do security in the future. Let me give you a couple of examples. So let's say I'm running, I don't know, however many servers I've got here. Let's just say it's 10, just for a round number. So I've got 10 servers, 9 of them are identical, they all match the gold standard, one of them has an additional listening port. Which server should I worry about? This one's easy, right? And quite honestly, this one isn't even almost not worth talking about, because any security admin worth their salt would find this with an Nmap scan, right? This is the type of stuff we look for every day. Okay, what about this one? What's wrong with this picture? Anything? Somebody logged in, they got the password right on the first try.
Why'd you even log in?
Why'd you even log in? Exactly. As we said, these are clones. I'm not patching or anything else. Now, I may need to. It may, you know, grand scheme of the universe, anything's possible. This might be legitimate. But as part of the normal process, I should never have to log in. So someone logging in correctly on their first try, are you going to catch that with your logging system in a Gen 2 environment? Absolutely not, right? This is what we want to say. We look at this and we say, oh, good, Bob was having a good day for a change, right? Got it on the first try, there's not, you know, 5 password failures, and then they actually get in. So we look at this as good, but when you can get this type of visibility, and again, this could be 150 servers rather than 10, this sticks out like a sore thumb. What about this one? I'll give you a hint, I'm picking on the same VM over and over again. But what have I got here? I know I've got 3 missing patches on my gold standard master, right? All my systems have those same 3 missing patches, except this one box is patched and up to date. Well, that means that box is okay, and it's the other 9 I got to worry about, right? No. What might cause this?
Somebody patching it for you?
Somebody patching it for you, right? Because there's a lot of folks out there that are really, really nice. They're really helpful. And they go around and they're not breaking into your system because they're evil. They're breaking in because they just hate the fact it's not patched and they want to make sure it's patched and up to date. So they will patch it to make sure no script kiddies can get in besides them. And then, you know, but they'll maintain access to it later because, you know, they might need to get in and check the patch level to get in now. But, yeah, exactly right. Typically, when somebody breaks in, one of the first things they may do is install all of those patches you missed to make sure some script key doesn't get in exactly the same way they did. They went to all the trouble of owning your server. They want to make sure they maintain that ownership. This is how it happens. This is what we refer to as a positive exception. In other words, no missing patches, good, yet in this condition, that's a problem. How often are you going to catch that in your logs? Quick show of hands, how many of you have ever caught that in your logs and really tagging that? My hand's up for a reason, I have. This is where we're going with security today. So when you start talking about public cloud systems moving around and all these other things, it can be like, oh my God. There's some things here, I'm telling you, that actually make life a whole lot easier. It's all in how you want to go through and kind of perceive these things. But you need to kind of build it into the whole process. If you keep building servers like you do in Gen 2, yeah, public cloud is going to hurt. It's going to hurt a lot. But adapt, change the way we do builds, this becomes a whole lot easier. So what I see in most sites is they may have not one gold standard image, but they may have three. So they have one for like the databases servers, one for their web, front-end facing web servers, and another that's like a generic server depending on what their needs are. But still, it's only 3 to work with as opposed to 100, 150, or whatever the case may be. Yeah, and no more one-off audit. In other words, we're not looking at that server, then looking at that server, then looking at that server, then that server. What we're doing is we're correlating data, and we're saying what makes any of these servers different from the others, especially that protected gold standard master. It makes life a whole lot easier. So, that's a little bit of a quick overview of what we're dealing with public cloud security today. What about trying to apply PCI compliance to it? And I hear this all over the board. It was really funny because I did a panel with, so I was involved with the PCI Council created this group, the PCI Cloud SIG group, to write a guidance document that was 50 plus pages in length, and I was one of the folks that was involved with that. Once that document was released, of course, everybody was like, hey, so look, we can do PCI public cloud now, and what's involved with that. And I was on a panel discussion at some place with a couple of folks. 2 of them were longtime PCI auditors. And one of them adamantly, no way you can get PCI certified in public cloud. Dude, it's the dog. No, I don't care. You can't get certified in public cloud. Yeah, you can. And folks have been doing it for a while. Amazon's been PCI certified for in the EC2 environment for 3 years now, 4 years now, something like that. I think 3 years now. So it's been going on for a while. Folks are getting certified on top of that. The biggest thing to deal with is this whole PCI scope thing, and we'll come back and we'll kind of talk about that as we go through. But when you talk about, so let's say I've got servers in public cloud. I'm going to be hosting credit card data on them. I need to receive my attestation. What's the process for receiving that attestation from an auditor? There's 2 ways to do it. The easy way and the hard way, which is why our guidance document ended up being over 50 pages in length, even though the PCI DSS itself is only about 70. The easy way is to go to a service provider, like Amazon, who's already PCI certified, like Amazon, get their gap analysis, go through define your scope, and I'll talk about what that means in just a minute. Have your auditor check your gaps, and you're done. So in other words, if your cloud service provider already has their PCI attestation, if you can show that to your auditor, and show the auditor, here's the PCI control items they're taking care of, and then you fill in the rest, bang, you're done. So this actually becomes a pretty easy process. The hard way to do this, and the one that took the longest to describe in the document, because you always want to make sure folks have a plan B in case they need it. I can't imagine anybody wanting to do this, but, again, wanted to give folks plan B. And that is, work with a cloud service provider that has not already received their attestation. And basically, you need to pay your auditor to go through their environment and give them your attestation. In other words, your auditor is no longer looking at just your environment, it's looking at your cloud service provider's environment as well. They're going to do the whole thing at your cost. Oh boy. So you can do it if you want to, but this is the way, this is the easy path. That's the one we really, kind of put out there for folks to say, this is the way you want to go. So this is right out of that CloudSig document that I mentioned. So here's our main control points here. Here's 3 different service models here. And you'll either see both client or CSP listed. What does this mean? This is, in general, who has responsibility for this control line under each of these different deployment models. Now, if you remember the drawing I showed you back at the beginning of this with the squiggly little red line, where the provider was responsible for more of the stack than the tenant, as you move from infrastructure up to service, up to software, you'll notice that here, CSP, very little responsibility. Here, oh yeah, they get a whole lot more. So again, how much of your PCI responsibility, if you will, that you can outsource depends on the service model that's involved here. So some of these will say CSP, some of them will say specifically client. Notice you never get rid of everything. Some of these are listed as both. Why both? Well, if it's software as a service and they're taking care of the hardware, they're taking care of the operating system, the application stack, and the databases, and the interface, and all that stuff, how could I ever, how can I end up with any responsibility at all, right? Shouldn't that PCI attestation basically be a get out of jail free card now? Because the SaaS provider's taking care of everything. Well, the way PCI is written up, you can never outsource everything. Excuse me. Assign a unique ID to each person with computer access is one of these specific control points. No shared accounts. A CSP has no control over that. If they're both part of the same company, I can't tell if they're sharing the same account or, if there's actually only one person sitting behind that keyboard. If your CSP can figure that out, be really afraid. Be really afraid. And do what I do and, take a little sticky note and put it right over the top of your monitor. Yeah. Like that. Best piece of security I've ever invested in. But you get the idea. So you'll never totally get rid of this, but you can kind of play around with how much you have to deal with depending upon which type of provider you go with. So first you need to kind of pick who you want to work with. So let's say we want to put some servers out there or we want to outsource some of that, but we don't want to give it all up. We want to be able to maintain security for ourselves just because we're paranoid, and paranoid is good. So we decide, okay, we're going to go with an infrastructure as a service provider. Then we say, okay, the easy way is to go with the infrastructure as a service provider that already has their PCI attestation. Amazon is a good choice for that. Okay, we're going to work with Amazon. So let's say we decide, okay, we're going to work with Amazon. Now we need to get our attestation. So how do we figure out which of these points we need to deal with? Sign a non-disclosure with Amazon or with anyone who's PCI certified or has the PCI attestation. And what they'll give you is a gap analysis. Basically, the gap analysis says, here's what we'll take responsibility for. Here's what you're responsibility for. So it's basically an Excel spreadsheet, for all intents and purposes, that's going to go through and list out every single PCI control item. So in this case here, we've got item 9.1, appropriate physical controls need to be in place. And your provider will give you something like this. So here, Fubar Cloud Services is claiming we maintain all physical security. We take care of that for all in-scope services. Cool. So now when your auditor is auditing you and saying, okay, what do you do about physical security? If all your servers are on Amazon, you say, Bill, look at them. And look, they have auditors that have already given them an attestation for this control point, therefore you don't need to worry about it. In other words, another auditor has blessed it, therefore it's okay to let it run. Cool. You're also going to see lines that are something like this. So here's 131. The requirement here is make sure you set up DMZ, make sure you have proper firewall rules in place, you've segregated the DMZ from the internal network, etc., etc. And here, Fubar Cloud Company is saying, okay, we'll give you the interface, we'll give you the software to implement firewall rules, but you need to read them, you need to write those rules. You need to architect your own environment. So you're only getting a partial pass here. So they're giving you all the software you need to get this done, but you need to actually go in and write and maintain rules. So some of it down, some of it still falls into your lap. But again, this gap analysis is what's going to give you all that. So, just to kind of review the process, understand credit card flow. So know what touches or processes that credit card information. Anything that touches or processes it, for all intents and purposes, is probably going to be considered in scope. Identify everything that's going to be in scope. And now look at, okay, which of this is being maintained by my cloud provider, which of it's being maintained by me. As part of defining scope, don't forget anything that may have admin access to your box. So for example, I've seen a couple of folks get bit by this. So they've gone with Microsoft's In Control SaaS solution. Basically, this is management of your Windows desktops, but it's a SaaS solution. So you don't need to install a server and run hardware or software and deal with it. You just sign up for Microsoft, pay them a per-seat license based on how many systems you have running on a regular basis, and it just runs that from there. The kick, though, is that it has the ability to go in and manage user accounts, which means you could potentially use In Control to go in and add admin access, which means if that system is being used to process credit card information, that now brings Microsoft's solution in scope because they can manage the admin account. You need to make sure they're PCI certified or you can't use them. So again, you need to kind of, sometimes scope can quickly run off from a tangent. You need to be able to keep an eye out for that. But flow this out, know how everything goes, and like I said, then it's just a matter of going through the gap analysis. So what confuses auditors? Because I've been talking to a few. What are the things that they look at that they say, yeah, I'm not sure how to deal with this? The first one is, what's gap analysis? Yeah, this is tough. I'm seeing still quite a few PCI auditors out there that have that attitude of public cloud, no way to get certified. You can't do it. So if you're using public cloud services and you're looking at getting your attestation, make sure you're dealing with an organization that's done this before. I think I mentioned GuidePoint, who's one of the sponsors here, are folks I've worked with specifically with these types of environments, so I can tell you that they have a clue. But you're not going to run into that everywhere. So if your auditor doesn't know what a gap analysis is, it's a warning sign. The other thing you start running into is kind of interesting things like this, where internal and external has no meaning anymore. So I mentioned I work with organizations where their corporate network is a couple of access points and it's a NAT-based connection to the internet, and that's it. So one of the things PCI mandates is that you label your hardware so you can identify if someone like Josh comes in and plugs in a rogue access point. Because now if someone plugs in a rogue access point, they may be able to get backdoor access to your network and get access to systems that people on the internet can't, and that would be bad. Well, if I don't have any servers on my internal network, who cares, right? So literally, I have environments that I've been dealing with where they encrypt everything and they handle their corporate network no differently than they do coffee shops and people's home networks. So now this requirement of, oh, you got to be able to identify if somebody installs an access point, who cares? Doesn't matter. You can go for an exception for that. Because if somebody plugs in an access point, they can't do anything with it. Also, that kind of hits this one here. In the past, we've had this concept of trusted networks. My internal network is trusted, my external isn't. We kind of think, we've been kind of taught, especially by Cisco and others, to kind of process it that way. One of the things I love about public cloud, this whole concept completely goes out the window. There's no such thing as a trusted network anymore. Because typically, my virtual machine has an IP address, maybe one IP off from hers, but we're totally different companies. So no, we're not going to trust that network, thank you very much. I'm going to make sure that host is locked down as much as possible, and anybody who can get to it now becomes problematic. Now, this introduces some interesting concerns. So I have a web app front end and a database server that need to be able to talk to each other. And I want to be able to clone that web app as needed based on load. And oh, by the way, I may decide I'm going to put some instances over in rack space too to kind of balance some of this stuff out. How the heck do I deal with all of this when we go? One of the cool things coming out of the tools today is that they're actually able to adapt to that. The company that I just left, Cloud Passage, one of the things they do is they rewrite firewall rules on the fly as you need it. So you take that web app server and you clone it. Their software figures out, oh, hey, this server was just cloned. There's 10 more instances of it. I need to make sure I apply the same security rules to them. No, the database server normally lets that web app front end talk to it. So these 5 new clones that spun up, I'm going to modify the database server's firewall to let those 5 systems in as well, regardless of the fact that they happen to be sitting over on rack space now instead. So this stuff is getting more virtual, more mobile, more flexible, but that also can make security a little bit more difficult to deal with. Questions on any of this? I know it's Monday, it's Saturday. Go for it.
So we talked a lot about the PCI compliance perspective of this.
Yes.
Do we still have the trap of compliance is not security?
So, good question. Question was, so we talked about PCI compliance with this. Do we still have the trap of compliance is not the same thing as security? Absolutely. Absolutely. So, one of the best security solutions I've found for dealing with public cloud is the whole cloning thing I was talking about that. PCI does nothing to address it. And as part of writing the guidance, I actually wanted to try and get some of that stuff in. And no, we can't go that far on a tangent. You know, in other words, the controls that are in there are not applicable. So I'm trying to write, here's how to deal with this control that no longer applies to the fact that now we're in the cloud, and you really need to change the control. So yeah, you're absolutely right. I don't think that will ever go away. Any other questions?
Will we ever get to FISMA compliance?
Will we ever get to FISMA compliance? I think 2 vendors are already there. So yeah, that's coming and it's coming quickly. Yes?
Seems excellent if I'm going to build an environment from the ground up. How are you seeing migrations and crossovers and all that kind
Very
of stuff?
carefully.
Yeah.
So the question was, yeah, so this makes it easy when it's get built from the ground up? Absolutely. Yeah, I deal with a lot of industry insiders, people who watch trends and stuff like that. And one of the things, you know, they look at and they say, oh, well, you know, I've been watching Liberty Mutual and they're not really pushing in public cloud, therefore it's not being adopted. No. So go back to the 1990s, right? Mainframes, PCs. Who adopted PC use first? Small startups, right? And then the enterprise companies that had this big investment in the hardware, they kind of dragged it to a kicking and screaming and slowly adopted it from there. So when you look at what's going on in the industry, you have to separate out Generation 2 versus Generation 3 companies. And then look at the trends separately because they're going to trend different. Gen 3, they're all over this. Oh my God, you cannot get investment money anymore unless you're going to throw all your servers out in public cloud. Because if you have a new widget you want to sell and you're trying to get, you know, investors to come in and invest in that, they don't want to invest in a network infrastructure. They want to invest in your ability to sell widgets. So new startups, they're all going cloud now. Generation 2, yeah. So now what you're looking at is we've got this internal investment. We want to leverage it. But you know what? Folks are doing cool stuff over there. We want to check it out. I will say, I'm seeing surprisingly large financial institutions that are starting to push into that space. I don't want to say quickly, to be careful, but oh yeah, it's happening. And you know, they're spinning up instances, 4, 5-digit range for numbers of servers. So process that a little bit. One last question before we're going to be done. Okay, I'll take 2.
How do you prove segmentation from a cloud provider's other customers?
Good question. Question was, how do you prove segmentation from other cloud providers? You really can't. So what I look at it as, I can't trust anything around here. All I can trust is what I can control in that VM. Therefore, I am going to document that VM as much as possible. So if everything goes into hell in a handbasket outside of it, can I still validate my integrity on the VM? Cool, then I know I'm okay. So that's how I handle it. But there's a couple other possibilities I could catch you after. And there's one more over here.
Yeah, question, how do you see like the small, medium businesses, like under 100 people using this? And then the other one is, what about actually the small businesses that are international? Do you see problems with safe haven and other things like that.
So, two-part question. One is small businesses, how do I see them dealing with this? They're adopting this in droves. Like I said, I'm dealing with multiple environments, no internal servers. So if you think about it, in order to spin up a server, I need to figure out the Amazon interface, or I can hire an admin to build a piece of hardware with software on top of it, pay for licensing. Oh my God, why would I ever want to build it? So it's a little bit of a better way to go. As far as regulations, yeah, that's a problem. And I've run into that. I've run into a situation where I was doing some consulting for a company that had data on their server that required it to stay in the United States, and their cloud service provider was pushing stuff out to Taiwan or Hong Kong, one of the two, and their servers were spinning up over there and they didn't even know it. So so dig this one. One of the cool things coming out with servers today, geolocation capability. Where is that server actually running? There's a big need for that in the market too. Cool. And I'm going to be done, we'll get other folks, but I'll hang around out back if anybody's got any questions.